Hi and welcome back to Gaffy's Grinds. This is video 7 in our series on junior cycle electricity, and in this topic in this series of videos we have been trying to take junior cert electricity, break it down into small manageable pieces, give you guys lots of practice to master the content before building on that with the next topic. You should know the rules by now, guys. I always ask you to eliminate any distractions by especially closing your social media tabs, closing any extra tabs open on your computer that you don't need, and try and stick your phone onto do not disturb mode. It's the #1 distraction that we all have. And as usual, this channel is different from others in that you get a lot more opportunity to practice questions. So it's really important that you take that opportunity. If you don't, then you're not going to learn very much by watching these videos. So do take advantage of the opportunities to practice and correct your work. Okay, so in today's video, we're going to start off by a quick reminder of a couple of things. So I'm just going to pause the screen while I switch to the simulation. Okay, we've seen the simulation before, and this is something that we've used the simulation before, and the link will be for it in the description box again. We are going to be using this today. But before we get into today's content, I just want to remind you of something that we've seen already. Here I am taking a power supply, a battery cell, which is a source of potential difference in the circuit. I then have a wire, and we're going to connect it up and we're going to make a circuit. So just very carefully, if we think about it, we have a circuit here made of a bulb, 2 wires and a battery. As you can see, once it's looped, once I've got a full connected loop, my electricity will begin to flow. I can see this because I can see these negative electrons moving in the circuit. Now I can get an idea as to how much or how fast they are flowing by just watching the electrons. So clearly I can see there that the speed of the electrons, we call this the current, is, you can have I don't have a number for it, but you can put a rough guess on, just eyeballing it, how fast are those electrons going. Now, I just want to point out to you something, a key point that we've probably seen already, that if I right click or if I click on this battery, and you guys could do the same thing, what you'll see is you can change the voltage or you can change the potential difference. And we've seen already that by increasing the potential difference, what I do is I increase the current. So you can clearly see a difference there. The electrons are now moving faster and my bulb has got brighter. But looking especially at the current, the electrons are moving faster. So if I put it away up, you can clearly see the difference there. Okay, so that's the first thing to note, that the higher the potential difference, it increases the current. So increase in potential difference increases the current. If I decrease the potential difference, what do you think is going to happen? So speak your answer on 3. 1, 2, 3. Okay, hopefully you said if I decrease the potential difference, then the current will decrease. And as you can see, as I bring down the potential difference, the electrons are slowing down. Another thing to note is, okay, so we're going to set the potential difference to 10 here. I'm going to set it to 10. And actually, no, I'm going to set it to faster, so it's more obvious that they're going faster. I'm going to set it to 70, sorry. Let's set the potential difference to 70. Now look at the speed of the electrons. Get a good eyeball of how quickly they're going. Now I'm going to break the circuit, and I'm going to put in extra resistance. And we do this by putting in another device which supplies a resistance. So I'm going to use another bulb like this. Now, as you can see, I'm hoping you realize that that the electrons are going a bit slower when we've got the 2 bulbs. If you're not convinced, let's put in another one. So a 3rd bulb provides more resistance again, and hopefully it's becoming more and more obvious that the electrons are getting slower each time we add a resistance. I'm just going to go back to our OneNote page, and we're just going to summarize that so far what we know. Okay, so far we've seen roughly that if we increase the voltage in a circuit, increase the potential difference. I'm going to show this by saying if I increase, showing an arrow going up for potential difference, which we measure in volts. Increase voltage How does that affect the current? 1, 2, 3, speak your answer to the screen. Increased voltage increases the current. What's the symbol for current on 3? 1, 2, 3. The symbol for current is a capital I. Okay, so increased voltage increases current. So just be clear, this here is current, and this one here is potential difference. Sorry, that's not very tidy. Potential difference measured in volt. Okay. We call the relationship between voltage and current, we call this I'm going to write it in a different color. We call this a proportional relationship. And what that means is that if you increase one relationship, if you increase one, you do the same to the other. So if I increase voltage, I increase the current. If I increase the current, I increase the voltage. If I decrease the voltage, I decrease the current. So whatever I do to one, it has the same effect on the other. We call this a proportional relationship. So the relationship between voltage and current is a proportional one. If instead of increasing the current, I increasing the potential difference, I would fix the potential difference. So it's leave at 10 volts. And I decide again to change the resistance by adding an extra bulb or an extra device. How will that affect the current? On 3, speak your answer to the screen. 1, 2, 3. Okay, so increase in resistance decreases the current. Okay, so what I did to the resistance, the opposite happens to the current. So if I was to decrease the resistance instead of increasing it, then I would increase the current. So whatever I do to one, the opposite happens to the other. We call this type of relationship an inversely, and inversely just means like opposite, I suppose, but the word is inversely proportional relationship. So that means that whatever I do to one thing, if I increase one thing, the other thing does the opposite, it decreases. Okay, so these are two really important relationships that we've already seen, but we probably haven't written them down before. So what I want you to do now, as I'm just going to write down here that this is resistance, what I'm going to get you guys to do is I'm going to get you guys to pause the video and take down that little bit of stuff there. Okay, we're now going to use the simulation to do an experiment to prove these two relationships and to take a little bit closer look at them. Before we do, I'm going to do some questions, and I'm going to give you a scenario. Okay, in the first experiment, we will use the simulator to build a circuit with one lamp. So we're going to have a circuit with one lamp. So obviously, the resistance is whatever the one lamp provides. So if the resistance of the lamp is 10 ohms, then because I'm leaving it as one lamp in there all the time, then the resistance is going to stay at 10 ohms for the whole time. So we say the resistance is fixed because we only have one bulb and we're not adding any extra bulbs in this first experiment, we'll say. What we're then going to do is we're going to slowly change the potential difference. We could do this by adding batteries. So add extra batteries, you increase more potential difference, or change the size of the battery. So instead of using a 3-volt battery, you could use a 6-volt battery, or you could use a 9-volt battery, or you could use a 12-volt battery, so on. So you can change either the number of batteries or the size of the battery. That is going to increase or change the potential difference for you. And then we would measure the current with an ammeter. So this is going to be a proper, an experiment where we're going to have variables. So think about control variables, independent variables, and dependent variables. So you're going to be asked in a second to do some questions about this. Okay, now, my class will definitely have done these types of variables before, but if you guys have not, if you're watching this and you have not, then do try and find a video on the channel about experiment variables. Right, so what I'm going to get you to do is I'm going to get you to pause the video, and I'm going to just get you to do the first 3 questions first. So I want you to pause the video and do the first 3 questions. So you have to say what the independent variable is, then what the dependent variable is, and what the controlled variables are. Okay, so pause the video and do that now, please. All right, here are some tips. If you weren't able, you didn't quite understand, or you couldn't remember which variables were which, these are some of the things you need to think about. So I'm going to give you some tips and clues, and then I'm going to give you an opportunity to pause your video and take another look. The first thing is, what is the independent variable? And the second question says, what is the dependent variable? So these are 2 very different types of things. And a key word here is the second question says dependent. Okay. So a dependent variable, the outcome of the dependent variable is going to depend on what you have done as a scientist to the other variable. Okay, I'll say that again. The outcome for the dependent variable depends on what the scientist did to the other variable. So the scientist changes the independent variable. The scientist then has another variable called a dependent variable that depends on the one that the scientist is manipulating or changing. So we say that the scientist measures the dependent variable to see if their changes to the other one have had any effect. Okay, so that's the difference between the independent variable is the one the scientist is going to change in this experiment. They're going to manipulate it or change it in some way. And then they're going to check the dependent variable, and they're going to see, is there any effect of changing the first one? Okay, so now that you've got that little clue, hopefully you might be able to do 1 and 2. Pause the video and try them now. Okay, let's have a look at our question. Which one were they changing? Which one they were measuring? Well, very clearly it states that the scientist is going to change the potential difference. And then they were going to see, did it have any effect on the current? So they were going to measure the current and see, did change in the potential difference have any impact on the current? Pause the video and answer questions 1 and 2 now. Okay, hopefully you said this. What is the independent variable in the experiment? Well, that is the one the scientist changed. So the potential difference is the independent variable. Well done if you said that. Good job. Potential difference. So the dependent variable then is the one that the scientist checked to see if the change in the potential difference had any impact. So what they did is they checked the current. So they measured the current and they checked to see if their changes to potential difference had any effect. Current is the answer to number 2. What about the control variables then? What ones did they keep the same? Pause the video and write your answer now if you don't already have it. Okay, well, obviously, they put 1 lamp into the socket. That is the resistance. They did not stop in the middle of the experiment and add more lamps or take a lamp away or change the type of lamp. So they used the same resistance all the way through. They probably also would have used things like the same wires. So you wouldn't stop in the middle and change the wires, because then that might have an impact on your results. If you use one set of wires and then use a different set of wires, it might carry the current or the potential difference slightly differently. So that probably wouldn't be a good idea to change the wires, the same wires. That's probably enough there. They're the important ones. Maybe the temperature. Temperature might have an effect on this. They would have done it in the same environment or the same temperature. Might have an impact on the current or the potential difference that we need to account for. Explain why they need to be controlled. Okay, so have a think about this one. Why is it important that these things do not change? Okay, think about what you really want to find out. So we're looking again at 1 and 2. This is the relationship we're really looking at. So why is it important that we control the rest? So pause the video and try and write an answer to that now. Okay, so explain why they need to be controlled? Well, they would need to be controlled so that the scientists would know that if they see a change in their current, that they know that change in the potential difference is what caused the change to the current. If they're changing the potential difference and they're changing the wires and they're changing the resistance, and then they see a change in the current, they can't then say, oh, potential difference, I changed the potential difference and it changed the current. Wait, but you also changed the resistance and you also changed the wire. So how do you know which thing it was that actually caused the change to the current? So explain why they need to be controlled. They need to be controlled so the scientist is sure about what is causing changes to the dependent variable is what they'll be checking and looking at. Dependent variable. So the scientist needs to be sure about what is causing changes to the dependent variable. If they let more than one thing change, so they let the potential difference change and they let resistance change and they let the wires change, then they can't be sure about what is actually causing the changes to the dependent variable. It's not a fair test anymore. So that's why it's important. So you should definitely mention about scientists being sure of, you should definitely mention there, you should have this phrase in there. What is causing changes to the dependent variable? That should be in your answer for sure. Okay. Now, the next two are going to be your personal predictions. What we call a hypothesis. You're going to be making a hypothesis here, which is a prediction before you do the experiment about what is going to happen. So you're going to be making a hypothesis. Before you do, just go back and read the actual brief again. What are we going to be doing? And your hypothesis, question 5, should start like this. I think that changing ... Okay, so you should start a sentence like this. I think that changing ... will cause ... Or if you don't want to say changing, you could say, I think that increasing or decreasing, or whatever way you want to put it, any kind of change that you might do. I think that increasing or changing ... whatever you think there will cause ... So you have to fill in that kind of sentence, but apply it to our problem here. Okay, so pause your video and try and do that now, please. Okay, hopefully you managed to use this writing frame that I've provided to write a good hypothesis. So let's have a look. I think that changing, right, well, what are we going to be changing? We're going to be changing the potential difference. Okay, so I think that changing the potential difference now I'm going to be a bit more specific. But changing doesn't necessarily really work here. So actually, we're going to say increase it. Okay, so if you didn't already, say what will happen if you increase the potential difference. I think that increasing the potential difference will cause ... Finish that sentence, please. Okay, well, what I think is going to happen is I think that increasing the potential difference will cause we're going to be measuring the current. So what's going to happen to the current? I think that increasing the potential difference will cause the current to increase. That's what I think is going to happen, because we already looked at the simulation and that's what happens. Okay, so I think the increase in the potential difference will cause the current to increase. Hopefully that's what you said. If you said, I think increasing the potential difference will cause the current to decrease, it's also a prediction. We're not sure whether it's right yet. We'll not know until we actually do the experiment, but it's still, no one can tell you you're wrong because it's still a correct statement. We just don't know whether it's actually true or false yet till we go and measure it. And still, you've made a valid prediction. So hypothesis, it can't really be wrong until after you've done the test. You have to go and prove it either right or wrong. Now explain your answer. Why do you think this? Okay, so pause the video and write an explanation for your answer. Okay, so there you might have said something like, I've already seen that adding more batteries in the simulation caused the bulb to get brighter or caused the electrons to move quicker, something like that. Okay, I'm not going to tell you exactly what way you should have worded that, because hopefully you have your own reason for writing that answer. Right, before we go and we do our experiment, we are going to need a little results table. So what I'm going to get you guys to do here is I'm going to get you to pause the video and take down this rough table. Now, you don't have to have all the box, even if you just have potential difference, current, even if you just have that, it'll be fine. Potential difference, current, and a left and right column. Pause the video and do that now. Okay, and now what you're going to need to do is you are going to need to go and open up the simulator that's in the link below. So I'm going to pause the video while I switch to that screen. Okay, this is the screen. Hopefully you've all managed to click the link below and open the simulator up. We're going to start by building a circuit. So I want you to pause the video and build a circuit with one battery and one bulb. Build a circuit with one battery and one bulb. Do that now, please. Pause the video. Okay, so you should only be watching if you have built the circuit. This is what you should have. That was a little bit more practice building circuits. So one battery and one bulb. There we go. And we have a simple circuit. I'm not sure if you realize that you can do this, but on this or in this circuit, what you're able to do is you are actually able to click the battery and you're able to select potential difference. So if I click the battery here, I can select the potential difference. So as you see, that's equivalent basically of putting in a bigger battery. So every time you change the voltage, that's equivalent in real life, if we had a real circuit, of switching the battery for a bigger one. So, you know, sometimes we have like the AAA batteries, and then we have AA batteries, and then we have like the C batteries, which are like a bigger, fatter battery. And then we have the D batteries, which are like the little square ones. And then there's an E battery, which is a big cube, kind of big block of a thing, and so on. So there's lots of different types of batteries. So increasing the potential difference is the same as putting in a bigger battery. Okay. What we can also do is we can set the resistance of the bulb. So if you click on the bulb, you can set the resistance. Now the stock here is to set the resistance to 10 ohms. And that's what we're going to leave it at. We're going to leave the resistance as 10 ohms. So on your table, you've got a place to fill in potential difference and current. So we're going to fix our resistance at whatever that bulb says. It says 10 ohms. So our resistance is going to stay fixed for this first experiment at 10 ohms. So it's never going to change. Always, it's the same resistance, just one bulb. What we're going to do then is we're going to change the voltage. And as we change the voltage, we're going to see how it affects the current. Okay, so we're going to start maybe with 2 volts. Okay, we're going to start with 2 volts. So what I'm going to get you to do is set your battery to 2 volts now, please. Okay, what we're then going to do is we're going to take our voltmeter, and drag it out. And what we're going to do is we're going to measure our potential difference across our battery and make sure that it is 2 volts. There you see, it is 2 volts. Sorry, I'm just going to need to, all right, this isn't ideal actually. We're going to switch. If you see down here, no, it's fine, never mind. We're going to measure, so we've measured our voltage, it's 2 volts. And what we're going to do is we're going to measure our current. So you take out your ammeter and you're going to pop this into the circuit somewhere along the circuit, and you're going to get a reading for current. So here you see, no matter where you put it in the circuit, the current is the same. It's 0.2 amps. Okay, so on your table now, you're going to record the voltage as 2 volts, so 2.00 volts. And when the voltage is 2.00 volts, the current is reading as 0.2 amps, like that. Okay, now So record those numbers. What we're now going to do is we're going to change our volt potential difference. We're going to increase it to 4 volts. Okay, so that's what I want you to do. Increase it to 4 volts. And we're going to measure the current again. Okay, so straight away here, you will see that no matter where you measure the current in the circuit, it is now 0.4 volts. Remember, we haven't changed the resistance. The resistance, we still have one bulb and our resistance is still 10 ohms. So that's staying the same. That is our fixed variable or our control variable. We're not changing that. We are changing the voltage and then we're measuring to see how does it affect the current. So 0.4 volts. All right, what I want you to do now is I want you to repeat this for voltages of, or potential differences of 6, 8, 10, and 12 volts. So pause the video and do that now, please. Okay, right, so you should now have a table with 6 readings. I'm going to pause the video for a second and go back to the OneNote screen. Okay, so just to be clear, what we should now have is we should now have this. We have potential difference of 2 volts. Actually, well, I don't need to write the V here because look, it's already incorporated. So you should put it up there as well. If you put it up there, then you don't have to write 2V every time. You can just write 2. So when the potential difference is 2, the current is 0.2. When the potential difference was 4, the current was 0.4. Now I'm guessing that when the potential difference was 6, you got the current was 0.6. How do I know that? Well, I see there is a pattern here or a trend, okay, which is that it's going up by 0.2 every time. So if this the potential difference is going up by 2, then the current seems to be going up by 0.2. That's what we were talking about before, what we call a proportional relationship. So as the potential difference goes up, the current also goes up, 0.8. This would have been 10, and this would have been 1, and then this would have been 12, and this would have been 1.2. So I'm guessing that that's the table that you managed to fill out. So what we're going to do is I'm going to get you to pause the video and answer questions 1 and 2 now. Okay, so describe the relationship between the potential difference and current. Okay, so describe. So you literally have to say what happens when you change one. What happens to one of them when you change the other one, basically. And then you have to explain. So to describe it, actually describe what happens. So we'll describe the relationship between potential difference and current. So when, you should have said something like this, when potential difference increases, we say the current increases. That's what we're seeing. Well done. If you said something like that, that describes it. That's all you need. When the potential difference increases, the current increases. Explain the relationship. So this requires a little bit more detail. You have to actually explain what you're seeing. Okay, well, this is where we might clarify that the relationship is what we call proportional. Okay, so hopefully you use that phrase in your answer, proportional. If you didn't, you should try and add it to your answer now. Relationship is proportional. Why is it proportional? Explain a little bit more detail. What's going on here? Well, we should be thinking about what the potential difference adds. What does it add to the coulombs of electrons that are moving in the circuit? What does the potential difference add to them or supply to them? It supplies energy. And when these coulombs of electrons have more energy, they move faster. So if you put a bigger battery in, it gives the coulombs of electrons more energy, and this is what makes them faster, move faster, sorry. So a higher potential difference supplies or transfers more energy to the electrons. And what does that do? Well, that makes them move faster. So they move faster. That's a pretty good explanation as to what's going on. They got more energy, they move faster, and when we measure it, this shows us that there's more current, because current is what we're doing. We're measuring how quickly the electrons are moving past a point, or how quickly a coulomb of electrons moves past a point. So remember, coulomb is just a really big amount of electrons. So the more energy they have, the faster they move, and the higher the current will be. Okay. All right, so hopefully you wrote something like that and you had some kind of a good explanation how relating, remember, energy from the so power supply to the current. So we now are going to try to repeat the experiment, but we are going to change, we're going to double the resistance this time, double the resistance by adding a second lamp. Okay. So before we go back and do that, we've got a couple of questions to answer here. So first of all, how do you predict this will affect your results? And explain your answer. So how do you predict that adding or doubling the resistance will affect your results? And explain your answer. So pause the video and answer those questions now, please. Okay, well, hopefully you know that adding a resistance slows down the current. We have seen this already. So how do you predict this will affect your results? Adding a resistance will, if it slows down the current, we can write this as reduce the current. But if you said slow down, then that's okay as well. Reduce is probably a better way of saying it. So adding a resistance will reduce the current. Explain your answer. Well, it's literally a fact that an extra bulb, or we'll probably actually we'll probably say adding a bulb in the first one. Adding a bulb will reduce the current. And explain your answer. Well, what's the bulb doing? Adding a bulb increases resistance. What does this do to electrons? This slows electrons all over the socket, or all around the socket. Making it harder for them to flow. The effect of this, when we measure the current, this reduces the current. So well done if you made those predictions. Okay, you might have used that exact wording, but check your answer for some key phrases. So hopefully you said adding a bulb, we add an extra bulb, it would reduce the current. And why? Well, adding a bulb increases the resistance. So we should definitely have referred to increasing the resistance in this answer. How does that, what does that do to the current? Well, it slows electrons and it reduces the current. Okay, so these are key phrases, key parts to that answer. All right, so when we do this, we're going to add an extra bulb and then we're going to use the same potential differences as you did before and measure the current. Okay, let's go and check. Go and check how this is going to work. So, all right, so we're back at our simulation. Okay, and we have our voltmeter and our ammeter. Okay, and what we said we were going to do is we're just going to add another bulb. So I'm going to cut the socket here and I'm going to add in a second bulb and connect them with a wire. Okay, now just check that both bulbs have the same resistance. So I'm going to click on it, make sure I get 10 ohms and 10 ohms. So the first time around, we only had one bulb that was 10 ohms. Now we have two bulbs that are 10 ohms So that will give us a total resistance of 20 ohms. So we have actually just doubled the resistance in the circuit. Now you can actually already physically see that the electrons are moving slower, but we're still going to measure them and double check. Now let's see, did adding this remember then our first voltage was 2 volts. So let's go back and use the same potential differences again. As you can see, yeah, you can still change the potential difference by changing what battery is connected. So we're going to say this is a 2-volt battery. Let's measure our voltage across the 2-volt battery. There you see the potential difference is 2 volts. And let's go and have a check of the current now. So when the potential difference is 2 volts, now the current is 0.1 amps. It doesn't matter where we measure it in the circuit, it's 0.1 amp everywhere. So 0.1 amp. So I want you to record those results in a second table. So just like before, the way you made a table, you're going to make a second table and you're going to record the results for the second experiment. So do that now and then do it for the same voltages and the same potential differences. Okay. So hopefully you can see there's a pattern. You can probably predict the results as you go along. I'm going to pause the video and go back to my original OneNote. Okay, so here is my second table. Now, actually, we should probably on your copy, just keep it a little bit tighter. We're going to call the first table. This is the first table, which we're going to call trial 1. It's probably a good idea to say what the resistance was here. This is for a resistance equal to 10 ohms. So it was a fixed resistance of 10 ohms. So in the same fashion, what I'm going to get you guys to do is tell me that this is trial 2. And what would we say here? Resistance equal to, what was the resistance here? I'm hoping here that you said it was 20 ohms. So it was twice the resistance of the first experiment. That's the only thing we've changed here. We've changed the resistance and we're going to see had it got an effect on the results. Well, as you can see, we still had the same voltages, so the same potential differences. We still did 2, 4, 6, 8, 10, and 12. And as you can see, the current this time has been reduced from the first time. So up here, it was 0.2 for 2 volts. Now it's 0.1. 0.4 then is 0.2. This would have been 0.3. I think that's what you would have got anyway. This would have been 0.4. This would have been 0.5, and this would have been 0.6. So it's basically half the current of the first time. So we've doubled the resistance, and that caused the current to half. So remember, we've used the same potential differences as in the first trial. The only thing we've changed is that this time the resistance is twice as much, and it caused the current for each reading to be half. So essentially, if you increase the resistance, the current decreases. That's what we've seen there. All right, so pause the video and you've got 2 questions to do there, please. All right, so as you see, sorry, there are questions 4 and 5. If you didn't see them there, I do want you to pause the video and do those, please. Okay, so it says you should see that the current in the 2 experiments is different. Describe the differences between the 2 experiments. Okay, so describe the differences. So basically what we've seen is the current readings, or the current readings in the second experiment are lower. How much lower? It happens that they're all exactly half. They're lower and they're exactly half the readings from the first experiment. Now, I'm just going to check my question, see if I've answered it. I'm going to read my answer. The current readings in the second experiment are lower. They're half the readings from the first experiment. I'm just going to go and check the question, make sure I've answered it. You should see that the current in the two experiments is different. I have addressed that. Describe, it asked me to describe the differences between the two experiments, the differences. Well, I think I have done that. I have said, I've described that the current readings, that's what's different. The current readings are lower and they are half the readings from the first experiment. I'm pretty happy with that I've answered the question. I have described the differences between the two experiments. I have referred to the first experiment and the second experiment. I then have to explain why are they different. So what is it that's changed that's made them different? Explain why they're different. Okay, so pause the video, try and explain why are the answers different. All right, so hopefully you referred to, well, what's the only thing that's different? In the second experiment, there are 2 bulbs. In the first experiment, there was only 1. Adding the second bulb has increased the resistance. So explain why they are different. In the second experiment, the resistance is higher. How much higher is it? It's double. The electrons are slowed down. And the current is lower. Brackets, how much lower is it? Well, each reading is half. Half as fast as in the first experiment. Okay. What you have looked at today, and it turns out that what you already know, or what you've just figured out about resistance, potential difference, and current fit into an equation, a physics equation or a law. And the law is called Ohm's law. And it's the same Ohm, the name of that gives its name to the unit for resistance, Ohm's law. And it goes like this. This is the formula, okay? So I'm just gonna pause the video. I just need to move that down out of my way. Okay, so we've seen that the current relies on 2 things. The current is equal to, well, it relies on the potential difference. It depends on both of these things. The current depends on the potential difference, and it also depends on the resistance. Now, how do I know which one is on top and which one is on the bottom of this formula? Well, it all has to do with the relationship. The current and the potential difference are proportional. A proportional relationship is shown by 2, basically, when we're talking about a proportional relationship, the proportional relationship variables will be the numerator, like this. When we have an indirectly proportional relationship or an inversely proportional, it will be a denominator in an equation like this. This is what we call the denominator of a fraction. This is a fraction denominator. Let's quickly give you an example of how this works. Say we want to know what the current is. We've got the current, which is I, and we want to know what is the current, question mark. If the current is equal to, and imagine for a second we're going to fix the resistance as 10 ohms. Okay. If I set the voltage to 1 volt, so I'm saying the voltage is 1, or the potential difference is 1, then we say the current is 1 over 10. Quite a small number. Now, what happens if I increase this? What happens? Say I say we're going to double the potential difference. We're going to leave the resistance the same. Well, then it becomes 2 over 10. So we're going to say I now is equal to 2 over 10. Which is a bigger current, 1 over 10 or 2 over 10? Hopefully you realize that 2 over 10 is a bigger number than 1 over 10. What if we increase the potential difference again? We say I is equal to 3 over 10. So now we've left the resistance as 10, but we've increased the potential difference again up to 3 over 10. What's happening to the current? Is the current getting bigger or smaller? The current is getting bigger. It's now 3 over 10. So as we increase the current, or the potential difference, as we increase the potential difference, the current increases. What about if we want to know what the current is and we're fixing the potential difference as 1? Fixing the potential difference as 1 and we're fixing the resistance as 1. Well, that means that the current is equal to 1 over 1, which is equal to 1. What if I say, what is the current when the potential difference is still 1, but the resistance I'm increasing? I'm going to say the resistance now is 2 instead of 1. So here, see, I have increased the resistance by adding an extra bulb, for example. Well, what has this done to the current? Well, the current used to be 1 over 1. That's 1 over 1. 1 divided by 1 equals 1. Now it's 1 over 2. 1 divided by 2 is only 0.5. So hopefully you can see that this has reduced. So when we increase the resistance, we reduce the current because the fraction number here ends up being a smaller number. And that's because resistance is in the denominator. What if we went from, again, so we went current equals, so our potential difference is still 1, but now we're increasing our resistance to 4. What's happened to the current? Well, the current now equals 1 over 4. As a decimal, that's 0.25. That has reduced again. So when we increase the resistance in the denominator, you decrease the current. Okay, so this here is what we call Ohm's law, this formula here. It's called Ohm's law. Now, I'm just going to make more space here. All right. It can be written like this. I equals V over R. This is Ohm's law. Now, we're not going to practice using that in this equation in this video. We will do that in the next video, where I is equal to current, V is equal to potential difference, and R is equal to resistance. This here is Ohm's law. And it's one formula that we're going to have to learn. Now, you can learn it by understanding the relationships. If you understand that current and voltage are directly proportional or proportional to each other, then you will know that V, when you want to find I, V is on the top. When you know that I and R are inversely proportional to each other, well, then you know that R is the denominator. Okay, so that is, you have to learn the relationship, which will help you rather than just trying to learn off the formula. If you try in detail to understand the relationships, then it makes it easier to understand the formula and be able to think about what the formula is if you forget, or rather than just learning it off. Okay, so think about it again. So without looking at the screen now, I want you to try and figure out what the formulas are. Okay, so think about it. We've got current, I. Current equals what? So think about current is, what happens to current when we increase the voltage? We increase the voltage, the potential difference, the current increases. That means they are proportional. If they are proportional, that means that V is on the top. hopefully you're trying to stay ahead of me. That means that R, resistance, is in the denominator. When it gets bigger, if this gets bigger, current gets smaller. So if we increase the resistance, we decrease the current. All right, so what I want you to do is I want you to make sure that you have that taken down and labeled. All right, so that is Ohm's law. So what is Ohm's law? That's what the video has been about, is doing an experiment and proving the relationships and building up to understanding the formula. In the next video, we're going to look at how we can apply that to solve some problems in circuits. Okay, so that is today's video. Do stick with it. I know that looking at those relationships can be challenging the first time, but do stick with it. Try and really understand the relationships, and that will help you work out the formula rather than just learning it off. If you can't understand the relationships, I suggest you watch parts of the video again. And if all else fails, then you will just have to try and learn the relationship or learn the formula, even though I prefer if you understand it. Right, that's the end of this video. I will see you in the next one, guys. Okay, thank you.